Good morning everyone. In this quick tutorial we are going to discuss how to design the mega PV system or large scale PV system using the PVSyst program under 30 minutes. If you are new to our channel, we provide electrical videos about electric circuits, power electronics, electrical machines, solar energy, power electronics, MATLAB, ETAB, and lots of topics which are important to electrical engineers. So don't forget to subscribe here now before you continue this video. Okay, so let's go to the PVSyst program and start designing our mega PV system. So let's start by going to the PVSyst program. Here in this lesson I'm using the PVSyst 7.0, the newest version in 2020. Okay, since a lot of my students are asking what is the difference between the newest version and the old version. So I'm using now a trial version for the PVSyst. You can try it. You can find it from their website. You can have a 30-day free trial. Okay, so how can we design the mega PV system or the large scale PV system? First, you have to know that since we are talking about mega PV system, therefore we are talking about a grid connected system. We are injecting this amount of power, large scale, into our grid. So when you open the PVSyst 7.0, you will select the grid connected system. One click. You will find that the window here is similar to the older version. So the first thing, you will put the project name. For example, Egypt mega PV system. Okay, as an example. That's the first step. Second step, you would like to add your own location. So we'll click on this button, new site, like this. Then you will find the menu similar to the previous versions. Okay, so we'll find here from the map you can select your own location, or simply you can go to Google Maps. Okay, like here. Then you can select the area you are in. For example, here if we go outside like here, you will find the map of the world. Okay, so I'm going to Cairo for example. Okay, and choose this location. For example, I would like this location. Okay, so I will right click. Then what is here? Okay, you will find here this is the latitude and longitude of the location. Click on it. Then take it from here, from this part here. Right click, copy. Then go to the PVSyst program. Then right click here and paste. Then click on search. Okay, so the PVSyst will take the longitude and latitude and longitude of the location and find it. Similar here, this is the location, similar here inside the Google Maps. Okay, now the next step is that we will click on accept the selected point. Okay, so now it takes the latitude, longitude, attitude, time zone and everything and put it inside here. Okay, now the next step is that we need to import the monthly data as well as the hourly for the radiations and all of the data we would like to use. Okay, we have a different methods to import from, but I'm usually using the Meteonorm 7.3. In the older version you'll find 7.0, 7.2. Okay, since it is the last version, you will find here a Meteonorm 7.3. Okay, now click on import to import the data from the database of the program. Okay, so now it provides the data for different points such as velocity, wind velocity, temperature, humidity, irradiation, and lots of data which are going to be used by the program. Okay, then we are going to click on OK, then save. Okay, yes, save. Okay, so now we added our new location here. Now the next step is that it says the comment has been modified. Please save the project. So I will save the project from here. Save. Then you will find here the blue box here shows you what you are going to do next. Okay, so it says the orientation is not defined. Okay, so I go down here, the orientation. Then it will tell you first what is the field type. Okay, you have a different tilting options such as the fixed tilted plane, or tracking vertical or tracking horizontal. Different methods here you will find here. We can discuss them in another video. Okay, but for now, for example, I am going to use the unlimited or the horizontal axis unlimited trackers. So we have unlimited number of trackers in the horizontal direction. Okay, controlling in the horizontal field. Okay, so you can then click on OK to choose this, or at first I would like to show you the fixed tilted plane which we usually use. You will find here the quick optimization, what you would like to optimize. Would you like to optimize according to the yearly irradiation yield, or choosing the tilt angle or the inclination angle which produces maximum power with respect to the whole year, or you would like to produce maximum power during summer, or you would like to produce the maximum amount of power during winter. So for example, if you choose yearly irradiation, you will find here this is the optimization is done by the program here. Okay, so you can also click here and change. You will find here the change in the tilt angle and the loss factor here, this one. Okay, so if we change in like this back to 30, it will be 0%. Okay, or negative 0.2, whatever it is. You can see the change in the tilt angle and the amount of the power which will be produced. Okay, and you will see that here we can also change the azimuth if you would like to do it, but for me, I'm going for this tutorial, I'm going to choose the horizontal axis unlimited trackers. Then click on OK. Then please define the system. So we will go to the system. Then first step, you would like sizing. What are you going to do? The sizing here, please define the desired power, kilowatt peak, or the available area for the PV system. So for example, I will choose the desired power, the power required. For example, I would like 1 mega watt peak, which means 1000 kilowatt peak. Okay, so we have 1000 kilowatt peak, which means 1 mega. Okay, now second step here, you will see please choose the PV module. Okay, so you can select the PV module similar to the previous versions, all manufacturers or all modules available now. Choose one of these years, whatever you would like to do. For example, available now, and you can choose the company of the PV modules you would like. For example, I am going to choose the Geneco Solar. Then you click here to choose what type of module. You will see here 215 watt peak. This is the maximum power produced at the STC conditions. 21 volt. Here SI silicon poly. okay, and the year of the manufacture and the model number. Okay, so for example, I'm going to choose this one, for example. Okay, this silicon mono. Okay, now you will find here the data sheet for the module itself. If you would like to see it, click on open. You will see the different data about the PV module here. You will find here the short circuit current, the maximum current at maximum power, the temperature coefficient, the voltage, V open circuit, short circuit current, the maximum voltage, the voltage at maximum power. You can see here also the length, the width, the weight of the cell, the module itself, the module area, number of cells in series and in parallel, the VI characteristics. You will find here also the shunt and series resistance for the modeling of the PV module itself, and different additional data such as losses and etc. Okay, so this is just so that you can see the data sheet of the component you are using. Okay, now the next step, please choose the inverter model. The total power should be 718.2 kilowatt, the optimal or more. Okay, so we should have at least 718.2 kilowatt optimal power. Okay, so you can see also here available now or all inverters similar as the PV modules. Here you will find that all manufacturers such as ABB or whatever the company you are using. For example, I will choose General Electric. Okay, this is just a tutorial for you. Okay, if you would like to see the data sheet, again you can click here on open for the selected inverter, and you can see everything about the inverter, including the efficiency curve. For example, here you will find here the efficiency, the power input, DC input power, and you will see the efficiency of the module, okay, of the inverter. Okay, so before we get to this, first you will see something here. We will choose first our inverter. Okay, for example, I will choose 1000 kilowatt inverter like this one. Okay, when you choose this inverter, you will find it is 1000 kilowatt, and the range is from 450 to 650. This is the operating voltage, the input DC voltage to the inverter. Here's the frequency 50 or 60 hertz. Here you will find the maximum voltage, maximum DC voltage, which can input inside the inverter itself. Okay, and you'll find here number of inverter. We choose one inverter of 1000 kilowatt. Okay, now see here that the program automatically, according to the inverter, it gives you the number of modules in series, number of strings in parallel, automatically, okay, to produce this amount of power. Okay, and you'll find here the voltage of this PV system, PV array. You'll find here a voltage at maximum power at 60 Celsius degree is 459. So 459 is inside the operating voltage. Okay, and also the maximum power at 20 Celsius degree, maximum voltage at maximum power is 542 volt, which is also inside the operating voltage. Now, if we are talking about the open circuit voltage at negative 10 Celsius degree, it will produce the highest voltage, which is 706. This voltage is not in the operating voltage, but however, the inverter can withstand it because the maximum input is 750. Okay, you will find here also the data about the short circuit and the current at maximum power. Okay, and here this is the output power at 1000 watt per meter square and 50 Celsius degrees, this irradiation and this temperature, and here at STC 1001. This is the array output power. Okay, you can see also here number of modules used inside this system, the area needed to produce this system, number of inverters, the nominal PV power, power produced at STC, maximum PV power at these conditions, and the nominal AC power, or the AC power at the nominal PV power. Okay. Now, what I would like to say here is what? If we go here to inside the inverter itself, click on open. Okay, efficiency curve. You'll find something here. We choose at 1000 kilowatt. Okay, so at 1000 kilowatt, the efficiency is 100%. Okay, this is the efficiency. This is the input DC power. At 1000, it is okay. Less than 1000, it is okay. Okay, you will see that you can use power, DC power will be reduced until a certain amount of power, the efficiency will start to decay till reaching close to zero. Okay, so what is the benefit of this? The benefit of this is that when you choose your own grid inverter, you have to make sure that for example, to have to see this curve, the efficiency curve for each inverter. Why? Because if the inverter is overloaded, for example, this inverter is 1000 kilowatt. Okay, so if the input PV produces, for example, 1200, like this one, you will find that the efficiency is nearly 80% or larger than 80% by a small value. So it means that it has a low efficiency at the case of overloading. Okay, now if we are underloading the inverter, you will find it preserves its efficiency. Another types of inverter, you will find the reverse. When you are underloading the inverter or reducing the inverter itself have a power lower than the PV panels, you will find that the reverse will happen. The efficiency will start to decay. Okay, so you have to see the P efficiency curve or the relation between them. Okay, this is important for you. So now we sized all of our components. You can see the simplified sketch. We have the PV array connected to an inverter, then it converts DC to AC, going to the grid. Okay, you will see also here system overview. The PV array, number of modules, the nominal power, area, and everything else. Okay. Now another point before we go to the next step, let's choose another one so that I show you something here. Go down here. For example, let's choose this 133 kilovolt. This one. Okay, this inverter is 1000 kilowatt, but it has something which is different. What is it? Not the operating voltage and not the input maximum voltage. Of course, they are different, but it has an inverter with a 2 maximum power point tracking. What does this mean? You will see that here number of maximum power point inputs is 2 and use multi maximum power point feature is tagged. So what does this mean? When this feature is tagged and this inverter has 2 inputs, what does this mean? It means that as if our converter or our inverter is divided into 2 equal inverters. Okay, so having this multi maximum power point feature means that our inverter will be divided into equal number of inverters. So how many number of inverters? It depends on this number. This numbers means we can take from 2 different arrays. Okay, one array having its a positive and negative, and another array with another positive and negative. Okay, so what is the benefit here? The multi maximum power point feature, it divides the power into two inverters. One inverter, inside it each input is divided into equal parts. One maximum power point input takes 500 kilowatt, another input takes 500 kilowatt. But for example here, in this example, 200 string. So what does this mean? It means that one input will take 100 string, another input will take the other string. So I know that it may be confusing, but it is really, really important. So in order to understand this, let's draw like this. Another one here. Okay, this one, assume for example that this one is 100 string. Okay, and this will form finally here positive and negative, and this other string will produce also positive and negative. Okay, now we have our inverter like this. For example, this is our inverter. Now this inverter have two maximum power point input. Okay, so this is the first one, this is the second one. Okay, now we will connect the positive with the positive, negative with the negative, this positive with this negative. Okay, now if we have the multi maximum power point feature is working, what does this mean? It means that this one will take 50% of the inverter power, and this one will take the other 50. Okay, so as if we have a 500 kilowatt inverter and another 500 kilowatt inverter. Okay, if we have a multi maximum power point feature, what if we don't have it? If we don't have it, then the inverter itself will divide the load naturally according to the number of strings here and here. As an example, if we have, for example, a 200 strings here, okay, 200 strings, and we have 100 string here. So this one is not equal to this one. So if we use the maximum power point tracking feature, then there will be unbalance between the two, or one of the maximum power point tracking will be overloaded. Okay, since each one has a 50%. But if we don't use the multi maximum power point tracking feature, then the inverter will naturally divide the loads. For example, this one will take 2/3 of the power, or 2/3 of the power, and this one will take 1/3 of the power when we don't activate this one. Okay, but we assume that they are divided equally, since we have a number of strings like this. Now click on OK. Then you will find here different things such as the detailed losses. Here you will find that the constant loss factor here is 20 watt per meter square Kelvin. This and there is a wind loss factor. So these are different loss factors which can be help in adding losses inside our system. Okay, then after finishing everything, we will click on run simulation. You will see that here it will provide you with all of the graph different from the previous version of the PVSyst. Okay, now after finishing, you can click on report here. So it will give you a detailed report for everything. Here, for example, this is our location. At the beginning, you will find here the number of trackers used. Okay, the width, the right, different parameters. Here you will find the modules, the number of modules, the power produced, the current, everything. Okay, and here you will find the PV array loss factors. Second page will give you the different factors for sunlight, such as the refractive index of the glass, refractive index of the air. Going to page number 3, here you'll find the data. For example, the performance ratio 78%. Okay, it is usually between 70 to 90%. Depends on the losses inside our system, shading effect, different parameters used. Okay, but this one is acceptable. Okay, here you will find the different months of the year. The performance ratio different from one month to another. Some months is high, some months is low, and here is a bar graph for it. Okay, and you'll find also the energy of the array. For example, here 102.2, and this is the energy going to the grid, 99.6 megawatt hour. Okay, and at the different times of the year. Going to number 4, here you will find here a graph for the incident kilowatt hour per meter square per day, and the energy injected to the grid. Okay, from the beginning of the year to the end of the year. You will find here also the PV modules, PV field orientation, tilted. Also you'll find here number of modules. Here the nominal power, PV power, and here's the nominal power of the inverter and the model of the inverter, model of the PV panels used or the modules used. Here you will find the graph for the losses inside the system itself. Okay, now another thing you can see, you can get only the tables, any type of table inside it. You can click on table and get it. Different options you will find it here. Another one here is the predefined graphs. You will find also here different diagrams. For example, the system loss diagram, which we have seen inside the report. This one. Okay. The most important thing is that you can find here the economic evaluation. So if you click on it, for example, you can use any currency you would like. Okay, and you can put the input of the PV module price, each unit, the price of each unit, the price of each tracker, the number of inverter, the price of each inverter, the installation costs such as the transport, wiring, etc., the insurance. Okay, the land costs, the loan bank. If you are taking a loan from the bank, you can put its amount, or land rent, the insurance, bank charges, taxes, a lot of points which you can find. Okay, so all of this will give you an economic evaluation for your own system. Another thing you will find here also the carbon balance. Okay, for example, here our system will save 20,983 tons of CO2 or carbon dioxide per year. Okay, so assuming that, of course, this project will remain for 30 years and annual degradation of 1%. Okay, so this can help you inside getting different certificates. If you have a factory, you can use and operated by PVSyst. You can get certificates which verify this, that you are helping the environment and reducing the emission of the CO2 or the carbon dioxide gases. This will help you in saving money and selling these certificates for large amount of money. Okay, so this system or this tutorial showed you how to do a grid connected PV system or a large scale PV system, mega PV system, using the PVSyst program. We use the 2020 version. So if you like this video, don't forget to subscribe to our channel and hit the like button. Thank you and see you in another video.